Hello and welcome to Higher Maths Differentiation and Curve Sketching. So in the previous video we looked at stationary points. So we're going to just extend that one step further and have a look at some curve sketching. So in order to sketch a curve we need to know three things. We need to know the x-axis intercepts, the x-intercepts, or the roots. To find those we solve for y equals to 0. Because on the x-axis the y-coordinate is 0, so that's why we're doing that. We need to find the y-intercept, and on the y-axis the x-coordinate is 0, so we just substitute x equals 0 into the equation that we're given. And we also need to find the stationary points and their nature, which is what we've been doing on pages 22 to 25, which you guys should be quite good at by now, or certainly getting the hang of, so it's more practice at doing that in this exercise. So example, sketch the curve with this equation. So we're going to find the x-intercepts first. So first of all, we set y equal to 0. So again, what we're doing here, we are finding out the points where the curve crosses the x-axis. So 1, 2, 3 points here, the y-coordinate is 0. The curve might not look like that, but I'm just using this diagram to explain what we're really doing. So let's say the y-coordinate equal to 0. So it's 2x cubed minus 3x squared equals 0. So we're looking for a common factor here, a common factor of x squared. So we get x squared bracket 2x minus 3 equals 0. So either x squared can be 0, in which case x equals 0, or the bracket can equal 0, in which case x would equal 3 over 2. And we know the y-coordinate is 0 already, so we don't need to substitute these values of x back in to find y, because we've set y equal to 0 to find these values of x. Because we've got 0, 0, that's actually going to be the y-intercept as well, but let's just go ahead and double check that. So substitute in x equals 0. Again, why we substitute in x equals 0? Because at the y-intercept here, the x-coordinate 0. That's what the x's stand for. In this equation, the y-coordinate anywhere on the curve is double the x-coordinate cubed minus 3 multiplied by the x-coordinate squared. So got 0, 0 again. So we've got the points where the curve crosses the x and the y-axis. Now we're going to find the stationary points. So this is a recap of the previous exercise. So we differentiate. We state dy dx equals 0 for stationary points. We must state that every single time, guys, so please do so. So set 6x squared minus 6x equals 0. Set 6x squared minus 6x equal to 0. Take out a common factor, so here we can take out 6 and x as a common factor, so 6x bracket x minus 1. So here 6x can equal 0, so that means that x equals 0, or x minus 1 equals 0, in which case x would equal 1. And again we need to substitute back into the original equation to get the y coordinates once we've done that. So substitute 0 in into the original equation. So that's definitely y equals we're substituting into. We're not substituting into dy dx here. So substitute into y equals, so substitute 0 in, we'll get 0, 0, 0 minus 0. If we substitute 1 in, we'll get 2 minus 3, which is negative 1. There we go. So we have stationary points at 0, 0 and at 1, comma, negative 1. Okay, so next thing we need to do is to find the nature of those stationary points. So again, guys, we know there's a stationary point at 0, so we need to look just before and just after 0. So I'm going to use the factorized form of dy dx. Again, you don't need to use a factorized form, but it does make it easier, which is why I choose to do it. So before 0 we have negative 1. So 6 times negative 1 will be negative. Negative 1 minus 1 will also be negative, so we've got 6 multiplied by negative, which will give a positive value. So before x equals 0, the curve is increasing. Okay, so I'm going to scroll down to the answer here. So what we found out there, we know there's a turning point at 0, 0, so we could mark that on. We know the x-intercept is at 3 over 2. We know there's another turning point at 1, negative 1. So what we've just found out is that before 0, when the x-coordinate is negative, the curve is increasing, there's a positive gradient, so the curve's coming up. So it's got to look like that. Substitute 0 in, just to check that we're getting a gradient of 0. So 6 multiplied by 0 is 0, so it's going to give a gradient of 0, which is a horizontal line. And then after 0, now we can't pick 1 here. Why can't we pick 1? Because at 1 there's another stationary point. So I'm just going to go down to what the curve looks like, so it's easier to explain. So we want to know what is happening between this stationary point and that stationary point. Okay, so to find that out, we've got to pick a value between x equals 0 and x equals 1. We can't pick 1 because we're going to get a gradient of 0 again, because there's a stationary point there. So we could pick a half or a quarter or 0.1 or 0.9 or whatever. It doesn't matter, because every point that I've just suggested there would give a negative gradient. So we'll just go up and make sure that it does come out as being negative. So let's pick a half. 6 multiplied by a half is positive. A half minus 1 is negative. Positive multiplied by a negative is a negative. So the curve is going to increase. The gradient is going to be positive, then 0, then negative. So it's going to go up, flatten out, and then drop, which is exactly what we're seeing in the diagram below. So maximum turning point at 0, 0. So we do need to state that that's a maximum. Right, what's happening at 1, at x equals 1? Well, before 1 we could pick a half, which we've already done up here. So substitute back in. We'll get a negative gradient. Remember, we can't pick 0. We normally pick a whole number, but can't pick 0 because there's a stationary point at 0. So we need to look between 0 and 1. That's very important. Substitute in 1 just to check. So 1 minus 1 is 0. So we've got something. Went on to the next page there. Sorry about that. So substitute in 1. 1 minus 1 is 0. It's got 6 multiplied by 1 multiplied by 0, which is 0. So it'll be a horizontal line at that point. And then after 1, so we can pick 2 because there's no further stationary points. So 2 is positive, 2 minus 1 is positive, so we've got 6 multiplied by a positive multiplied by a positive, which will give a positive number. So the slope will be increasing after x equals 1. So it'll be a minimum turning point of 1, negative 1. So this slope here shows that it's a minimum. The slope here shows that that's a maximum. So we've done all the work now. We just need to make a nice sketch of it. So we have the x-intercepts, we have the y-intercept, we have the 2 turning points. Quick reminder, guys, we know a cubic will make this shape. Okay, if it has a positive coefficient of x cubed, so if there's a positive number at the front of it, or it might make, rather than a maximum and a minimum turning point, there might just be a rising point of inflection instead. If there was a negative coefficient of x cubed, so if it was negative 2x cubed, it would basically fall, then rise, then fall again. So it'll be a minimum, then a maximum. Or there might just be a falling point of inflection. Okay, so if we've always got that in mind, that it's going to look like that, then we can, if it turns out that we get an answer like this, then we know we've probably got it 100% correct. Okay, so having an idea in your mind what the final answer is going to look like allows you to check your working, which is very nice in an exam, knowing that you've probably got a 8 or 9 mark question correct. So we've got the mark on the intercept, so 0, 0, 3 over 2. Mark on the stationary points, 0, 0, 1, negative 1. We know this is a maximum, so we could just sketch in that that's a maximum turning point. We know this is a minimum, and then we know the overall shape of a cubic looks like that. So we can just complete the graph. You must mark on the intercepts and the turning points. So just because you've got it written here that the minimum turning point is 1, negative 1, if you choose not to write that on your graph, you're throwing away a mark. And every mark is important, so please don't choose to do that. Okay, I'll do a separate video for the next question.